So combination just means series and parallel. So let's say I had a circuit here that was, okay, I'm going to put a resistor here, put a resistor here, two resistors here. Let's say we had a circuit like this. I have 1, 2, 3, 4, 5 resistors. Okay. All you need to do is use either. So don't use both rules. That's the only thing we need to avoid here, is use either series or parallel. Okay, series or parallel to combine two neighbors together. Okay, so just be careful. I can't combine these two right here that are in parallel because his neighbor right here is in series, right? So you combine two neighbors together. Be careful. I can't combine these two here because they're not really neighbors, because this is part of my parallel right here. So it'll take a little bit of getting used to, but it has to be essentially like your closest neighbor that you're trying to combine. Okay, so let's say this is R1, R2, R3, R4, R5. Okay, so the way I would combine this here is I would first try to combine these two, R2 and R3. They're neighbors, they're right next to each other. And I can say that R23 is the way I'll call it, is just R2 plus R3 because they're in series, right? They're next to each other, they're in series. So to combine them into one resistor is just adding them together. And then what happens to my circuit after I do this is I have a very similar circuit. Just copy it over. But now, instead of these guys here, I just have one resistor, which is R23. Okay? So I've replaced two resistors with one. Remember, this is equivalent resistor. I can do this. And then you do this again. You do this for parallel now. So now we do this for these two. And then when I write this down, I'll keep this as red. My R, now I'm going to call this 2, 3, 4, because 2, 3, and 4 together is going just to be 1 over R23 plus 1 over R4, and I'm going to do to the negative 1. Remember, this flips it over. So this is what, that does the 1 over part here at the end. So I need to do 1 over, and then at the end I'm going to do to the minus 1. That's going to flip it over in the same way we did right here. Okay? So that way I can just write it out. And then now these two will combine, and we'll have one last step to do, because I'll have my circuit now will be R1, R2, 3, 4, and R5. This is R1, R2, 3, 4, and R5, because now these two are combined into one. Okay? So now all three of these are in series. So I can combine all of them. It doesn't have to be two, it can be three or more. If they're all in series or if they're all in parallel, you can combine them all, right? So this is essentially 1, 2, 3, 4, 5. Is just going to be R1 plus R2, 3, 4 plus R5. And then this will give me my total equivalent resistance with just my one circuit with one resistor, where this is R1, 2, 3, 4, 5. Now be careful here. That doesn't mean, so it looks like we just added them all up here at the end, right? So what some of my students might do is they might see this and say like, well, eventually they're all going to be in series, so I can just add them all up, right? You can't do that. If you add up R1 plus 2 plus 3 plus 4 plus 5 from the very beginning, you won't get the same answer here. Because remember, we had to do this in the middle. Okay?